Hi and Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present our power system analysis group project, which is the analysis system for 3 machines and 9 bus systems. So power flow analysis is a very important and basic tool in the field of power system engineering. It is used in the planning and design stages as well as during the operational stages of a power system. Some applications, especially in the fields of optimization of power system and distribution automation, need repeated fast power flow solutions. In these applications, it is imperative that the power flow analysis is solved as efficiently as possible. With the development of microcomputer, distribution substation owned computer programs have become a necessity. The power flow model of a power system is built using the relevant network, load and generation data. Output of the power flow model include voltage at different buses, line flow in the network, and system losses. The outputs are obtained by solving nodal power balance equations. Since these equations are non-linear, iterative techniques such as the Newton-Raphson, the Gauss-Seidel, and the fast decoupled methods are commonly used to solve this problem. The problem is simplified as a linear problem in the DC power flow technique.
Assalamualaikum warahmatullahi wabarakatuh. I will present about the methodology. Load flow analysis. Load flow study determines the operating state of the system for a given loading. Load flow solves a set or a group of simultaneous nonlinear algebraic power equations for the two unknown variables at each node in a varied system. It also to solve nonlinear algebraic equations, it is important to possess fast, efficient, and accurate numerical algorithms. The output of the load flow analysis is that the voltage and the phase angle, real and reactive power, line losses, and slack bus power. Then, Gauss-Seidel method. It is used to determine the solution to a system of linear equations. The fixed point iteration approach is used in this method. It will begin with a guess solution to the supplied system, whether it's a program, algorithm, or flowchart. Iterate the equation until the desired level of precision is achieved. In Gauss-Seidel method, it have 16 steps total. Advantage of Gauss-Seidel method. First, the method is very simple in calculations and thus programming is easier. Second, the storage needed in the computer memory is relatively less. Third, in general, the method is applicable for smaller systems. Lastly, less computational time per iteration and useful for a smaller system. The disadvantage: first, effect on convergence because of the choice of stack bus. Slow rate of convergence loading to larger number of iterations. Third, for large system, use of Gauss-Seidel method is practically prohibitive. Lastly, the number of iterations needed is generally high and is also dependent on the acceleration factor selected. Newton-Raphson method. It is iterative technique for solving a set of various nonlinear equations with an equal number of unknowns. There are two methods of solution for the load flow using Newton-Raphson method. First method use rectangular coordinates for the variables, while the second method use polar coordinate form. Out of these two methods, the polar coordinate form is used widely. There are 11 steps total to use the Newton-Raphson method. Advantage of Newton-Raphson method. First, the number of iterations required is thus independent of the size of the system or the number of bars in the system. Second, the method is more accurate, faster and reliable. Third, requires a smaller number of iterations for convergence. In fact, in 3 to 4 iterations, good convergence is reached irrespective of the size of the system. Lastly, the method is best suited for load flow solution to large size system. The disadvantages of Newton-Raphson method. The memory needed is quite large for large system. Calculations per iteration are also much larger than the Gauss-Seidel method. Since it is a gradient method, the method is quite evolved and hence programming is also comparatively difficult and complicated. That's all from me.
Hello, my name is Sridharan Sivalingam. I'm from Smart Signal Group Project System Analysis. I'm going to explain about my part, which is result and discussion. So this is the result that we get for the Gauss-Seidel method in MATLAB. So the result of the value of active and reactive power of 3 machine 9 bus system and also line power losses all shown below. So this is the result for line flow and losses by the Gauss-Seidel method. Result for Newton-Raphson method. So value active and reactive also for 3 machine 9 buses system. And this is the result for the flow and losses by the Newton-Raphson method. So this is the coding that we use in MATLAB. Bus out coding, data bus, Newton-Raphson method. Y bus coding, main Newton-Raphson method for the coding, main Newton, yes, main Newton.mm for the method, Gauss-Seidel method coding in MATLAB. Line flow. So this is the main Newton-Raphson method coding. That's all from me. Thank you.
Hello, my name is Naveen Analulaki Suryakumar. My matrix number is AE190020. Now I'm going to present about the conclusion for this project. In this project, we are able to compare between Gauss-Seidel method and Newton-Raphson method for the analysis of the power flow. The main aspect discussed the analysis of numerical method performed by the interconnection bus system to manipulate and compare the calculation between two types of flow method, Gauss-Seidel and Newton-Raphson method performed from simulation. The Gauss-Seidel method is an iterative technique for solving a square system of linear equation with unknown x. The Gauss-Seidel method, also known as the Liebman method or the method of successive displacement, is an iterative method used to solve a system of linear equations. The difference between these two methods are the Gauss-Seidel method is very simple in calculation and thus the programming is easier compared to Newton-Raphson's method. This project can be achieved by using the MATLAB software, which is a tool to simulate all the data needed to ensure that all the objectives of this analysis are successful.